Now y'all can hear me. How's everyone doing today? Good. How's the conference so far? Yeah, good sessions? Everybody bright and awake, keynotes, all good, fun stuff? Awesome. Well, welcome. We are here to talk about price performance with SQL Server and Azure VMs. Is everyone in the right room? All right, cool. How many of you are actually using VMs in Azure? SQL Server VMs in Azure. Okay, most of you, that's good. For the rest of you, are you thinking about it? Are you here on an exploratory mission? Or you just wanted to hang out? Okay. No, that's fine. Yeah. Yeah, honestly, a lot of this, I mean, probably most of what I'm going to talk about is applicable to Oracle as well. I'm not really going to talk about anything that's like SQL Server specific. Really what we're talking about is Azure infrastructure. So this should absolutely be applicable. Yeah, okay, great. Awesome, and how many of you are DBAs? Oh, that's almost everybody. Infrastructure admin? Developer? Okay, manager? Okay, architect? Other sort of decision maker? There you go, okay. I'm like, there's one person who hasn't raised their hand. I'm like, some sort of IT decision maker. Okay, wonderful, welcome. So my name is Pam LaHood, and I am the lead PM for the SQL Server and Azure Virtual Machine team in Microsoft and Azure Data. We've been on this journey, this price performance journey, for several years now. And I also have a couple of colleagues in the room too. So we've learned a lot. And so this presentation that you're gonna hear today, I delivered it at PASS last year, I've delivered it at BITS, I've delivered it at user groups, I think I even did it at 8KB one time. And it's evolved over time as the options in Azure evolve over time. And so the whole point of this session is really to kind of familiarize you with the Azure infrastructure, some of the choices that you're going to need to make if you're migrating to Azure. If you're already in Azure, maybe some things you might want to rethink that might help you optimize not only performance, but price as well. So I already said all this. I'm the lead. Yep, I've been working with SQL Server for over 25 years, and 18 of those at Microsoft. So I've been around for a while. And you can always find me on Twitter at SQL Goddess. I'm also on that new Blue Sky thing if you're not an X fan. At also SQL Goddess. And then this is the SQL Server blog, which we do blog on occasionally. All right. So, and one more housekeeping thing. I am perfectly happy to take questions in line. So, and actually I kind of prefer it because then I get them in the context of the content. So if you have a question or a comment or something isn't clear, please feel free to speak up, raise your hand, or just shout out. We're all friends here. And so I'll take as many questions as I have time for. And then also, I'll be around today. So if you find me, feel free to pull me aside and have a conversation. We also have David Pless in the back, who is doing price performance now. We have Taryn in the front. She and I will be doing an HADR session at the end of the day at 4:45. And we have our engineering manager, Vakar, who's in the corner, who's gonna probably remain anonymous most of the time. But if you stump us with any really hard questions, we have Vakar in the back pocket. So that's the team. Understanding Azure VM options. So if you've already been in Azure, you probably have seen we have hundreds and hundreds of VM sizes that you can choose from. And it's a somewhat daunting task figuring out which is the right one that you need. So I will narrow this down for you. So on the screen, I have the different families of VMs that we have in Azure. And each family has some sort of specialty. So we have like the entry level, the really basic VMs. We have burstable VMs that can like burst CPU or shrink based on need. Compute intensive, memory intensive, GPU accelerated, high performance compute, all these different things. Storage optimized, and which one should you choose for databases? We will narrow this down to the basics. Now, obviously, the best thing for you to do is kind of monitor your workload and figure out which one is the best. But if you don't know where to start, there are two that we focus on, and that is the memory optimized, which is the E series and the M series VMs, and the general purpose and confidential computing, so the D series VMs. And the other VMs might be good for you if you have special needs, but these are the ones that are usually best suited for SQL Server. And the interesting one is the storage optimized too. You might think, oh, well, it's a database, I want to go for the storage optimized. But the storage optimized have a whole bunch of NVMe drives built into them. So yes, lightning fast storage, but it's ephemeral, which means if the virtual machine goes through a live migration to another host, you lose the data on those drives. So they're not durable, which means you can't use them for SQL Server database files unless you're doing something really clever with availability groups and you have multiple replicas. So even those may be enticing for SQL Server, we actually don't generally recommend them unless you have a special case where you can recreate the data on the fly. Okay, so these are the ones we prefer. Now within the ones we prefer, and this is gonna be a message that will be hammered home every time you hear me speak, the ones we really like are the EDSV5 and the EBDSV5, which is what we call, anybody? Anybody heard me speak before, know what I call the EBDSV5? It's powered by Microsoft Boost, that's one thing, but I have a special name for it. Double sprinkles, not just sprinkles, but double sprinkles VMs. So if you hear anybody say, hey, yeah, I'm using those double sprinkles VMs, that's the EBDSV5. So that's the ones we really like. And those are the ones that have the highest IOPS and throughput in Azure. That's why we like them. And I will talk much more about those in this session today. Okay. So a lot of times I get a lot of questions. What do the letters mean? What does the B mean? Why is alphabet soup every time I pick a VM? This is actually documented. I've got a link to the documentation at the bottom of the page. Believe it or not, all of those letters mean something. Okay, so I'm gonna actually go back one slide really quickly, and I'm gonna show you. So the EBDSV5, and then we have the DCSV2, and the DADSV, okay. The first letter, the capital letter, that should be the only one that's capitalized, is the first or the first two letters. Those letters refer to the family of VM. So the E series is the memory optimized, M series is memory optimized. So the family and the subfamily, that's the first one. In those DC, C stands for confidential computing. Those are the ones with the special confidential computing chips in them, right? So the capital letters refer to the family. It's usually just the first letter that's capital, sometimes the second letter if it's just got a subfamily. Then it will be followed by a number. The number is the number of vCPUs. So in an EBDSV5, an E8 BDSV5 is an 8 vCore VM. So family followed by number of CPUs, and then all the lowercase alphabet soup, those are the features that VM size supports. So so A would be an AMD processor. If it doesn't have an A, it's Intel. And then there's a whole bunch of other letters. The ones that you want to focus on for SQL Server workloads are the B and the lowercase d. So B stands for bandwidth. Those are the ones that have the high I/O bandwidth. Right now it's just the EBDSV5, but there may be more in the future. So keep an eye out for the B. And then D, the little lowercase d, stands for diskful, which means it has a local ephemeral drive available to you inside the virtual machine. Now, why is that important for SQL Server workloads? I just told you you can't put your database files on them. Which files can you put on them, though? TempDB. Yeah, exactly, TempDB. So TempDB is ephemeral in and of itself. If you restart SQL Server, you've got to recreate TempDB anyway. Put that on the D drive. Free IOPS, super fast. It's SSD, in some cases even NVMe. So these are fast storage, IOPS that don't deduct from your remote storage throughput. So really great place to put TempDB. And if you use our extension, the SQL IaaS agent extension, then we handle the situation if you fail over and you go to a new host and you lose your D drive. We handle recreating the folders and the files for you. So you don't have to worry about that management as long as you're using our SQL IaaS agent extension. So great place for TempDB. So I'll let you browse the other little letters, but remember, you can always refer to that document if you're not sure. Okay, there's one other little kind of trick you can do for SQL Server. So you may find a situation where you can't find a size in Azure that has the right number of cores matched with the right amount of memory and the right number of IOPS and throughput. So if you're in that kind of a situation, and you may find yourself having to go up in vCores in order to get more memory and more IOPS and throughput, What we do have available is something called constrained cores sizes in Azure. And with constrained cores, you can pay for the compute and the memory and the throughput of that larger size, but you can down core it so that you only pay SQL Server licensing for the smaller size. And that can save you a lot of money, because if you look at the price of your Azure virtual machines, especially the pay-go, more than half the cost is your SQL licensing. So using constrained cores can really help you save on SQL licensing costs if you have to upsize. Now, our goal is to build VM sizes for you that you don't have to use constrained cores on. That would be the ideal, and we're working on that. But for now, you can really leverage constrained cores to help fill that gap when you need a better mem to core ratio is usually what people use this for. Yes? Boost, not burst, boost. Yeah, yeah. Very good question. Do we have the constrained cores option available on EBDS v5? My answer to you right now is no, but we are working on something. So we hope to get there.
What is the, like with the boost series, what's the best scenario, like with the NVMe enabled Gen 2 VM with the boost series?
You know what, we're exactly, so she's saying what's the best practices, all these things combined, what's the best thing to do for that best configuration, right? That's what this presentation is all about. So if I haven't answered that question by the end of this session, then we will have a conversation. Actually, we should probably have that all together, because then it means I haven't done my job. Yeah, okay.
So going in that line, because that's really important, what you just asked, when will we have, like, you guys are...
Let's take that offline, because you guys are already talking with David, right? You've been talking to David, yeah. You guys are already talking to us, so we'll take that offline. Yeah, for sure. Okay, constraint course. Okay, so sorry, the way the constraint course works is if you see a number, not just one number, but a number and then dash another number, so in this case 32-16, it means you're paying for the 32 core, the memory and the throughput that comes with that, but you're only paying 16 cores of licensing, and only 16 cores will be available in the VM. So you're paying for the higher one, but you're not paying for the licensing. So that's what that number, if you see two numbers with a dash in between them, that's what that means. Yep, in the back. Question is, do we also have hyper-threading on and off options? That is not currently a public option, but I do believe there may be some work on that. You can actually contact support, open a ticket, and tell them to turn off hyper-threading, but that's not a public-facing option yet. Okay. All right, so what I want to talk about next is how do I figure out what these mean? So each one of these VM series, there's documentation about all the limits that it provides, but there's so many numbers, and if you don't understand what those numbers mean, it can be even more difficult to choose the right size. So what I want to talk about now is how does this work in Azure, and what do all these numbers mean? So this comes straight out of Azure VM documentation, and this is how the disk provisioning works in Azure VMs. So you notice I have, I'm sorry, my laser pointer is going to be hard to do here. Let me see if you guys can see my mouse. No, it's not working on the presentation. This is a little bit frustrating. Okay, let me see if I can laser point for you guys. So let's, oh, or not, wrong button. Okay, so start at the bottom here where it says Azure Storage Page Blobs, right? That's your remote storage. So if you connect like a premium SSD or premium SSD v2 or ultra disk, that's what we call remote storage, and it's under the covers, it's page blobs, right? So then there's server, oh gosh, I'm sorry. Okay, I'm gonna give up on the laser pointer. Server SSD. That's the locally attached storage. That's the storage that attaches directly to the host that you may or may not have access to. How do you know if you have access to that SSD? What are you going to look for in the VM name to know you have access to that SSD? You didn't know there would be a quiz this early, right? It's the little d, the diskful. If the VM size has the D in it, like EBDSV5, it means you'll have access to that local SSD that's attached. That's the ephemeral storage, the stuff that goes away if your VM migrates, right? Okay, so there are actually then 3 different types of provisioning and 3 different kinds of limits that the VM and the disks impose. So the first is disk level provisioning. When you attach a disk to a virtual machine, the disk itself will have limits, not just capacity, but IOPS and throughput limits. And that's how much that one disk is capable of. And that's what we call disk level provisioning. And then there is also VM level provisioning. So I gotta try the laser pointer again. So we've got disk level provisioning here. So you've got an attached remote disk level provisioning, that's the limit on the disk. And then look, you go through another box here, VM level provisioning. This is because, and I'm sorry, I'll try to do that over here. It's not working very well. So disk level provisioning, VM level provisioning, okay? So the disk is the limit that's opposed to the disk. The VM level provisioning is the total amount of remote I/O throughput that the virtual machine is capable of. So there's actually two limits here. You can get capped at the disk level, you can get capped at the VM level. And so that's where, and I'm going to tie this back to documentation in a minute so you can see how you know what these limits are. But you could be limited by either one of these. So you can attach as many disks as you want up to the limit of the number of disks that virtual machine supports, like maybe 16 disks or 8 disks. You can attach, and you can put all the IOPS and throughput you want if you're on Ultra. But if the VM doesn't support that many IOPS, you're not going to get that many IOPS, okay? Because you have to go out through remote storage, and that's going across the network. So you have to know there's disk level provisioning and VM level provisioning. Then I have this thing in the middle called cached managed disk. So if you're using premium SSD, you also have access to something called Azure Host Cache, or sometimes it's called Blab Cache or read caching. So there is actually a cache that's built into the virtual machine host that is a combination of memory and that local SSD that's attached to the host. So that cache is available to cache the remote storage. And so there is actually a separate level of SSD level provisioning. So when you carve out the size, you'll see another column that says local throughput. That's how much you get on the SSD. And if you turn on read caching, which we often recommend if you're using premium SSD, if you turn on read caching, then you're also bound by that SSD level provisioning as well. So 3 different levels of provisioning that we need to be aware of. Okay, so this is actually a simplified version of our documentation, because this is actually a little bit old. They've added all kinds of new columns. I'll talk about all the new columns they've added a little bit later, but for now I want to keep the simple diagram because it's going to make it easier for this conversation. So this is EDS v5, and then these are the different limits that you can see. Every single VM series in Azure has documentation associated with it, which will tell you the limits for VM level provisioning and local provisioning, SSD provisioning. Yeah, you have a hand.
Is the recaching, are you forced into it for premium SSD? Or
You're not forced into it. You can turn it on if you want. Yeah.
would you suggest to turn it off for the log drive and just turn it on?
Good question. We're going to cover that. So the question is, this cache, should I turn it off for the log drive, on for the, I have 2 slides on that, so we'll come to that later. Good question, though. Okay, so this is what the documentation looks like. Let's break this down. Okay, max uncached disk throughput. This is your VM level provisioning. So uncached disk throughput. That's what's going to remote storage. This is your remote storage limit, IOPS, and throughput, okay? Then we have SSD level provisioning, local provisioning, max temp storage throughput. This used to say max temp and cached throughput. It doesn't anymore because honestly your mileage may vary on read caching. You may or may not get the limits depending on the load on the system and which VM series you've landed on, like which hardware you've landed on. So they don't guarantee cache throughput anymore. But you can sort of imply that from your max temp storage because remember it's using that same SSD for the cache. So this would be the amount of IOPS and throughput you get on that local SSD that you have access to if you have the D series, the D sizes, the EBDS versus EBS. Okay. All right, so let's start tying this together to that original diagram I have. So now you can see I've circled one of the sizes, E8DSV5, which has a max uncached throughput of 12,800 IOPS and 290 megabytes per second. And I've projected that out into the original diagram. So I'm imagining that I have a single P30, which is a premium SSD drive attached. A P30 drive has 5,000 IOPS and 200 megabytes per second of throughput. That's how much the disk is capable of. That's the disk level provisioning. The VM is capable of 12,800 IOPS and 290 megabytes per second of throughput. That is the VM level provisioning. So again, that same box there where the VM level provisioning is. And then you see max temp storage throughput is 38,500. So that's the SSD level provisioning, which covers both the cache and the D drive. Okay, so generally what you would do is put your transaction log files on an uncached, so that answers one of your questions. For the transaction log, you would want to set host caching to none. So you would put your transaction log on an uncached managed disk. So that would be subject to the VM level provisioning. And then you would generally put your data files on a cached managed disk. So that also has the same disk level provisioning, but now you're going through the cache, which has more IOPS. So you could, in theory, get more IOPS there. And then this recommendation for caching, this changes a little bit with EBDSV5, but we'll also talk about that. So, and then your tempDB, again, put those on the D drive, and that has no caching, that's just the temp storage throughput. So that only hits the SSD level provisioning. Okay. Does that make sense? Any questions on that, the aligning of those two? Okay, great. So now we understand how the sizes work and what the limits mean. So now, how do I pick the one that's right for me? Oh yeah, question. Why for Intel did we offer 4 times write performance than for AMD? Are you saying the AMD size is in the EA DSP? You're saying that the read sizes are not the same as the write sizes on the AMD? I'm not sure. I was not aware of that. So let's connect offline and you can show me the series that you're talking about, and then I will see if I can get that question answered, because I've never seen that before. Okay, thanks for bringing that up. Okay, any other questions before we go to right sizing? Okay, how do we choose the right size? Okay, so if you want to do this yourself, if you want to roll your own, or if you already have, like, let's say you're using SCOM on-prem or something like that, and you already have lots of rich performance metrics, here's the ones that you want to look at. Now, I'm going to assume that you guys know how to size CPU and RAM, because most of you have been doing that your entire careers. So I'm not going to tell you how to size your CPU and RAM. I'll let you figure that out. I will tell you how to size your IOPS and throughput, because this is the one. Oh, yeah. Oh, thank you. I mean, I have it. I don't know. The problem is the angle, but let me see if that. Thank you so much. Well, that does work better. Thank you so much. Okay, and you know what? I actually got a brand new pointer. I just didn't even think to pull it out. Right, so I'll tell you how to IOPS and throughput. So perfmon counters, those are your friends. However you collect them. Either you collect them from perfmon, you can even get them through the DMVs in SQL Server if you want to, or if, like I said, if you have SCOM or something like that. However you collect, Idera, Redgate, I don't know, you pick your poison. You want to be looking at disk reads per second and disk writes per second. This is your IOPS, or the number of transactions against the disk. And then for throughput, read bytes per second and write bytes per second. Why is it important to look at these separately? Because if you choose caching, you're going to turn on read caching, but not write caching, and I'll talk about why. But so you really want to understand the difference between reads and writes a little bit, if you can. If you have cumulative, just throughput per second, that's better than nothing, but best if you can separate it. And then latency, I mean, latency doesn't always translate to the cloud. I'll be honest with you. I'll be totally frank with you, because we're all friends here, right? Your disk is going to be slower in the cloud. Why? Because it's remote storage going over the network. We can't bend the laws of physics in Azure as much as we try. But so it's probably going to be slower than what you have on-prem. But usually the SQL Server engine will absorb that. You know, so unless you have some really super tuned workload that is lightning fast and it's like has to be sub-millisecond latency, this is probably not going to be a problem for you, but it's a number that you want to be aware of, just so you know, right? But I wouldn't worry too much about latency, especially if you go with our premium SSD v2 storage. It's going to be plenty of latency for most of your workloads. So you want to measure these numbers, and then okay. So this formula I have on the slide, this is total back of the napkin math. This is not a precise formula. Your mileage may vary, but it roughly translates. If you turn on read cache, then you want to map uncached IOPS and megabytes per second of throughput to transaction log reads and writes, because those are not going through the cache, plus data file writes and about 70% of your reads, but that's going to depend on your cache hit ratio. So that's about the limit you need for uncached IOPS. And for cached IOPS, that roughly maps to tempdb because it's on the D drive, and data file reads and writes. Because even though you're not turning on write caching, if you write to the disk, it has to write to the cache as well. So that counts to both. So this is a rough back of the napkin math. And also, you don't have to do this yourself. So if you don't want to try to like, do all this analysis on your own, then of course we have a tool for you that will do this for you. We have a SKU recommendation tool. I like to call it David Plus in a box, because David did this original math and worked with the SKU recommendation team to set up the original algorithms for this, but they've evolved over time. And so this is a tool. You can get it through that Azure migration service, but also what is that database migration service? But it's built into Azure not built into Azure Data Studio. It is an extension for Azure Data Studio, although I hear that it's installed by default for new builds of Azure Data Studio. So this is an extension to Azure Data Studio, which has a SKU recommendation tool built into it. It allows you to collect your workload. And this tool is using the dynamic management views in SQL Server. And it will analyze your workload, and it will recommend for you a SKU, either managed instance or Azure Virtual Machine or Azure SQL Database, based on your workloads. And it can also do like functional analysis, so it can spit out, oh, sorry, you're using CLR, you can't go to SQLDB, you got to go to managed instance, something like that. Like it actually does functional analysis as well. So if you don't want to try to do all this math on your own, you can use Azure Data Studio to do this analysis for you. Also, if you're already in Azure, there are some right-sizing recommendations you can get through Azure as well. They're a little bit basic. I think your mileage may vary with those, but that may be another way to see where you have opportunities for either increasing your size, or they are even trying to do cost optimization. I'd be a little bit suspicious of the cost optimization if it's telling you that you can downsize, because it may not know that you have a variable workload, so take those with a grain of salt, but there are some recommendations available in Azure as well. So I have a short URL for you to the documentation for the SKU recommendations in Azure Data Studio. Okay. Any questions before we start talking about my favorite topic? Yeah, double sprinkles. That's also David's fault, actually, too, because he built the slide with the little stars on it. And when we used to talk about EDS v4, which was our favorite series before EBDS v5 came out, and he had the stars on it. And then when EBDS v5 came out, I got to put double stars. I'm like, I'm going to call it double sprinkles. So actually, it might have even been someone in a session that actually called it out to me, double sprinkles, whatever. Anyway, it's v4 is just sprinkles. This is double sprinkles. So when the next stuff comes out, I may have to have a contest, like a community contest, like name the new series. I was thinking Awesome Sauce for when a new one comes out that's even better, but I don't know, we'll see. When it's on the horizon, I'll let you all know. We can have a contest, a naming contest. Okay, so double sprinkles VMs. Why do oh, sorry, go ahead, yeah.
No, that's okay. So you said that there is some right-sizing Azure documentation, right-size of completion, the cost optimization, but we need to be cautious in terms of like variable workloads.
Yeah.
For that, do you guys also have a tool for cost optimization in case there's like oversized VMs with like vCPUs, but also lining up with the IOPS and the managed disk?
Right, so the question is, do we have a tool for the right sizing in Azure that can kind of help you with the cost optimization? That is all built into Azure, and it's using Azure metrics. So it's all in the portal. So they do have it, and our team evaluated the algorithm, and I think it's probably decent. I would always double check it. So I can connect with you offline, because I'm sorry, I did not think to put the links into the deck for that, but I can find the links to the documentation for the right sizing, and we can kind of talk through whether it's right for you guys, because I know you're in a big cost optimization exercise.
We do have direct access to Azure in the forecasting,
Yeah,
but in terms of like more complexity,
I think it'll do what you need it to do, but
it should be like very.
yeah, we'll take that offline. Yeah, for sure. Yes.
Well, is it smart enough to, well, I guess maybe it wouldn't be relevant in this case, but in the future, to recommend like constrained UVMs?
Would it be good to recommend, would the right sizing or you mean the SKU recommendation tool? Would the SKU recommendation tool be smart enough to recommend constrained cores? Yes, it will, if they're available. It looks at all the sizes that are available and picks the one that closest matches your workload. Yep, good question. All right, double sprinkles. Double sprinkles because it's the highest I/O throughput with the lowest core count, so the best I/O throughput to core ratio. And it was purpose-built. We worked with Azure Core to design a series that would work better for SQL Server customers. So this is done with you in mind, and it seems to be working pretty well because the adoption is pretty strong. And so coming out of the gate, if either you don't have good data, you don't have analysis, you don't have the ability to do analysis tools, or you just need to get into Azure and you're not sure what to pick, this is the one, okay? So it's got a 1:8 core to memory ratio, which is good for most workloads. And then the generally available sizes go up to 260,000 IOPS and 6.5 gigabytes per second of throughput, which is more than enough for most people's needs. And that top end is at either 96 cores or 112i. I is one of the letters I didn't cover with you guys. I means isolated, which means your VM is the only one on the box, which means you get a little bit of extra because it's not co-located with another VM. So you get a little bit of extra. In the cases here, the IOPS and throughput are the same, but you get a couple extra cores, and I think you might get a little extra on some of the sizes. So, and then currently in public preview, this is the boost powered sizes, and that's 400,000 IOPS and 10 gigabytes per second. That requires Microsoft Boost, which I think I added a slide here talking about Boost. But essentially, Boost adds a whole bunch of extra stuff into the back end, into Azure. Things like RDMA, better networking, offloading, like actually hardware offloading cards and things like that. Stuff that just allows us to give you a little more juice in the VM, no extra cost. This is just our upgrades on the back end in the data center. That's Microsoft Boost. If you were at Ignite, you'd be hearing a lot about Microsoft Boost. But it's less of a database thing and more of an Azure infrastructure thing. Yeah.
One question, so we have the presence in 17 regions.
Uh-huh.
And a couple of regions where we have hypercare critical clients, but with the burst series with the combination of NVMe is not possible. If burst series is there, VM cannot have NVMe next to the network. We are not able to get the
Yeah, so the question is, so one of the innovations that Microsoft Boost depends on is NVMe. You can't get these larger IOPS and throughput without NVMe interface, which is a separate interface. I have a couple slides about this. The question is, but it's not available in all regions. It's true, it's not available in all regions yet, but it will be expanding over time. Yeah, okay. All right, so as I said, EBDS v5, it's the double I lost a sprinkle. There's only one sprinkle on there. Okay, EBDS v5 double sprinkles. Offers the best price performance for SQL Server workloads. MSv3, these are the new medium memory M-series VMs that are coming up. M-series VMs have massive amounts of memory, like 2 terabytes, 4 terabytes of RAM. The problem is they're incredibly expensive. So your best bet is the E-series, which is memory optimized, but it's kind of more reasonably, it's one of our general purpose memory optimized. So EBDS v5 is the best one to start with. M-series, if you really need a ton of memory or you really need high-end machines. Those M-series machines, they go up to, this one is like 176 cores at the top end, V-cores, but the bigger ones can go up to like 832 cores. These are massive, like Superdome machines. So if you need that level of power, you can get it in Azure. You'll pay for it, but you can get it. So for most of you, I'm guessing the double sprinkles, the EBDS v5 is the right one. So, and then for your entry level, David likes to call it departmental workloads. I don't know what departmental workloads means. We actually did a poll in a session and nobody knew what that meant. This is your entry level, smaller systems. Maybe they just have a couple of packaged apps on them that are not particularly busy. DDSV5. So that one is slightly less memory, cheaper, entry-level general purpose machine. So that's good for those. And you can always pick smaller VMs for test machines, but I wouldn't go much smaller for a production machine. These are really the ones you want to look at for production. And like I said, there's a couple of specialized series out there if you have special needs, but these are the basics. So, oh, there's my double sprinkles. The animation was broken. Okay, and so again, when in doubt, pick EBDSV5, hashtag double sprinkles VMs. Okay. I will say one more thing before I move on to storage, and that is the best VM series for you is the one that matches your requirements. So you can take my word for it and just go to EBDSV5, but the better thing to do is download Azure Data Studio, try the SKU recommendation tool, see what it tells you. Because one thing that might happen that you might be surprised about is it might say you don't need a VM that's as big as this machine on-prem. Because what have we been doing for years? For years, we've been throwing hardware at the problem. We've been buying massive boxes, whatever happens to be commodity hardware at the time. You've been putting tons of memory in it, tons of CPU in it. You might not actually need that much. And so what that SKU recommendation tool will do is actually analyze your workload and say your CPU never goes above 25%. You don't need 16 cores. You can go with 8 cores or 4 cores. And don't worry about it, because guess what? If you get to Azure and 4 cores is not enough, what do? You click a button in the portal and you go to 8 cores. And it happens in less than an hour. It's like seconds sometimes, depending on what hardware you're on. In some cases, it might be just like that. You don't have to migrate hardware, you just get more cores. So use the SKU recommendation tool, use the monitoring tools you have, look at what you have and try to match that. Don't try to just do like for like. Don't try to just lift and shift exactly the number of cores in memory you have. Really look at what you're using and don't overpay. Because you get to Azure and all these people are spending so much money. It's so expensive being in the cloud. Not if you look at your workload. And what's the power of the cloud? Elasticity. You don't have to buy new hardware to upsize. You can upsize for Christmas and downsize after Christmas. Use Azure to help you meet your cost needs. Don't just lift and shift what you have. Yeah. If you may humbly add anything you like, yeah. Yes, okay. Okay, I see what you're saying. Yes. Sure. Yeah. Yeah. So what the comment is up here, the addition is if you are reselling on behalf of a customer, sure, you upsize it immediately in Azure, but you might not be able to pass that cost along to your customer for some time because it takes finance cycles and things to do that. So having projections is also a really good thing. So what does projections come down to? Monitoring. How close are you to the limit? Keep the same monitoring you're doing on-prem, you're doing the same thing. The difference in Azure is you're looking at a percentage of the total available. So instead of, you have 80,000 IOPS, let's say. How do you know how close you are to that 80,000 IOPS? We actually have metrics, and I have a slide on that too. We have metrics that'll tell you how close you are to the limit. So you're at 90% of the limit. You're at 10% of the limit. So there is some data you can get to in Azure which will kind of give you an idea of where you're at on that spectrum. All right, so we've been talking about compute, VMs, and now we will talk about storage. And again, if you've heard us talking, you might have heard already us talk about Premium SSD v2. This is the new thing. So there are many different types of storage in Azure. I will tell you for SQL Server workloads on Azure VMs, you really want to go with managed disk, and because of the features that are available as well as the performance. This is the best combination of feature availability and performance. And in the managed disk, there are 3 types that are appropriate for production SQL Server workloads. Ultra disk, which is super fast, high IOPS and throughput, but very expensive. Then you have the old Premium SSD. We call it Premium SSD v1, but that's not the official name. It's just Premium SSD. And that's slightly lower latency. Your mileage may vary, but lower latency than Ultra disk. But it's got provisioned IOPS and throughput, which means the amount of IOPS and throughput is tied to the disk size. So you want a 1 terabyte disk, you get 5,000 IOPS and 200 megabytes per second of throughput. You want more than that, you got to upsize the disk. So what we tell you to do is don't upsize the disk because then they get crazy expensive. Just pool them together in a storage pool and you get more, but that just adds complexity. So this new type of storage is Premium SSD V2. And it works a lot like UltraDisk in that you choose the size, you choose the IOPS, you choose the throughput. One disk, you choose what you want within the guidelines. And then you pay, you get 3,000 IOPS included, and I think it's 125 megabytes of throughput included in the disk. And then you just pay an incremental cost above that for the IOPS and throughput you add. And then similarly with capacity, you increase the capacity, it increases the cost. And you can adjust IOPS and throughput on the fly. So if you need more IOPS, you can push it up to the VM level limit. Remember, you can never increase the VM level limit unless you increase the whole size of the VM, which brings up your cores as well. So keep that in mind. But the Premium SSD V2 gives you a lot more flexibility. It's a much more cost-effective solution, and it's faster than Premium SSD. So this will actually not only increase the speed of your drives, but it will usually reduce the cost compared to Premium SSD V1, and it'll allow you to avoid storage pools in a lot of cases if you want to. Yeah.
One question here. Now, the baseline with premium SSD, we were given that it is supported with availability set, Azure backup, and all that extra things. And then we built our $1 million business with IS, lift and shift with all the data center. But now we are finding that availability set is not supported, it's supported through
V1, yeah.
Yeah, in V2, because it is there in V1.
Yes, they're in V1, but availability sets are not in V2, yeah.
Now the platform engineering team, they have to rebuild that all the VM images, they do not have that kind of stuff, and we have live clients sitting there. All we want is the move to everybody to keep premium SSD V2.
Yeah,
So it's sort of brilliance on the question in a way.
yeah.
The baseline should not change, right? Like when you go for the SQL version A to B or the next newer version, it's not something that what was in the previous version, now it is no longer there. These get deprecated, but there is a reason. But here now, we are stuck in a
Yeah, yeah, so I understand. Okay, so yeah, let me give you the bad news because I'm telling you only the good news. The bad news is Premium SSD V2 is not supported with some things like availability sets. It supports availability zones. In fact, it requires you to be in a zonal region, but it doesn't support availability sets. And there are a few other limitations like that. And so the comment is you went from V1 to V2 and you degraded all these features. Here's why. It doesn't excuse the problem, I hear you. Here's why. Premium SSD V2 is not an innovation on Premium SSD V1. Premium SSD V2 is a reduced tier of UltraDisk. So it supports everything that UltraDisk supported, and UltraDisk out of the gate have a ton of limitations. So when they started building Premium SSD V2, they knew this. They learned from UltraDisk, and they are working on those limitations. So they are definitely trying to knock those out. But they decided to GA before they had all that available because they're like, oh, it works great. I'm like, yeah, it works great as long as you don't have availability sets, Azure backup, Azure site recovery, encryption. There you go. Okay. So yes, there is some drawbacks here, but they are all being worked on, and there's roadmaps for all of them. And I know you're working with David on that, and we're definitely working on closing those gaps for you. But that's why, because it's actually UltraDisk with slightly higher latency. That's the deal that's happening there. But I hear you, like the perception is we took a step backward and not a step forward. Yeah, heard. Yep. Yeah. Those are independent of the, yeah, so the question is the free IOPS and throughput, are those independent of the size? Yes and no. There is some link, like you have to go beyond like 1 gigabyte. With 1 gigabyte, you can get up to, I think, 3,125 megabytes, but you may not be able to go higher unless you go up capacity. But once you're at the 1 terabyte range, you can get as many as this thing supports, which is 80,000 and 1.2 gigs. Yeah, so it's slightly tied to capacity, but it does scale independently. Yeah, okay. Okay, so you know what, I'm not even, I already told, if you do want to continue with Premium SSD, and you may have to because of the limitations we just talked about, we do recommend you stick with P30 and P40. Remember, this is the disk level provisioning. This is how much the disk itself is capable of, which you can see is kind of small compared to the others. The reason we recommend P30 and P40 is because once you get past P40, it no longer supports read caching or host caching. And once you go below P30, you can't do storage reservations. So the sweet spot are the P30s and P40s, where you can do both storage reservations, which help with cost, and caching, which also helps with cost, especially on the non-double sprinkles VMs, the ones that don't have the high remote throughput. You might be able to get away with less I/O throughput, but leverage caching. And the thing with caching is it's totally dependent on your workload, whether your workload can take advantage of it or not, okay? So that's premium SSD, and then Ultra Disk, like I said, if you've got deep pockets and a need for very high performance, Ultra Disk is for you. But the sweet spot for most people is the premium SSD V2. I can't call it double sprinkles. I'm going to have to come up with a new name for this too. But until they give you guys availability sets, I'll reserve a fancy name. Question, yeah. If you have large demands on storage. Oh, the VM level throttling. Yes. Yes, which is why the EBDS v5 came out. So they're saying if you have high demands for IOPS and throughput, these big Ultra disks are almost useless because the VM can't support it. Right. But you won't have that problem with EBDS v5 because you get 400,000 IOPS and 10 gigabytes per second of throughput. So there you go. Oh. Oh, I see. If you don't need the vCores, then yeah. But also, I mean, it also depends on how much I/O throughput you need because it is still pretty high in some of the lower core counts. Not for you. Okay, well, you know what? I would love to hear more about that workload because I'm constantly working with them and we're changing these numbers. So absolutely, I would love to hear from you. Yeah. All right. I would love to. Yeah. No, I hear you. I hear you. That's what our team is for. So let's connect after the session. I would love to hear more about your workload for sure. Yeah. Thank you. Okay. So EBDS v5 and Premium SSD v2 better together. This is the testing that we've been doing to kind of gauge how good this is. This is using HammerDB with a TPCC workload, and we went from $5.18 per 1,000 NOPM. NOPM stands for new orders per minute. That's the performance metric in the TPCC, down to $1.53 per 1,000 new orders per minute. And that's by not having to use constrained cores, moving to EBDS v5, and using Premium SSD v2 storage. So really big gains and this all comes down to being able to right size. It all comes down to not having to over provision in order to get the IOPS and throughput you need. That's where these numbers are coming from. It's really not magic. Okay. Okay, the plot thickens. So we talked about this a little bit. So what's this boost thing that we keep talking about up here? New sizes powered by Microsoft Boost. Right now, the only sizes powered by Microsoft Boost are the double sprinkles VMs. That's why they're double sprinkles. So in order to get the highest I/O throughput, there are two interfaces that you can connect your VM to storage. One is SCSI, which is the original interface and the default. And the other is NVMe. When you provision your VM, you choose NVMe, you will get higher IOPS and throughput. So when you build the VM, you need to choose it. Right now, if you choose EBDS v5, you'll get this little pop-up here that says, hey, you could use one of our new NVMe sizes. Click here to learn more, okay? Once you get that, you then need to go to the Advanced tab and click the box that says, yes, please, I'd like higher remote disk storage performance with NVMe. Check the box, and then you'll get the higher limits. And again, I'll give you the bad news too. There are some limitations here. NVMe is not rolled out everywhere. Okay, so you need to check and make sure it's available. So when you use NVMe and our documentation, all of this is going to get way more confusing. You remember that really simple IOPS and throughput slide I showed you before? This is what it looks like now. First of all, for EBDS v5, you have two sets of values, one for SCSI and one for NVMe, and you'll see the NVMe limits are higher. The other thing is UltraDisk and Premium SSD v2 give you more IOPS and throughput than Premium SSD in most cases. The only caveat to that is there are some locations that don't have RDMA enabled for Premium SSD v2. So and that's all reflected in the documentation. So you'll see exactly where it is. So eventually, they'll all be on par, whether it's Ultra Premium SSD v2 or Premium SSD v1. But for now, just look at these numbers and make sure. But you'll get higher IOPS and throughput in general using Premium SSD v2. So the documentation now has separate columns for Premium SSD and Premium SSD v2 and Ultra Disk, and it'll have 2 separate tables, one for SCSI and one for NVMe. Everything we talked about still applies. It's just now there's more options. Did you choose NVMe or did you choose SCSI? Did you choose Premium SSD or Premium SSD v2? These now all impact the VM level provisioning, not just the disk level provisioning. That's the thing that's a little bit more confusing. But hopefully, after this talk, you will understand how to interpret the documentation and figure out what you're going to get. Okay? Yes? Yeah. Man, that is a ringer question. Is there a REST API to get the limits out of the VM? Is that what you're asking? Yes. It does not yet have a way to distinguish between SCSI and NVMe, and it may not be accurate. So, sort of, I guess, is the best answer. But we're working on that too. Okay. All right, so NVMe. Currently only available on EBSV5 and EBDSV5. Pop quiz. What's the difference between EBSV5 and EBDSV5? D has a temp disk. Yes, my job is done. Okay. Okay, only available with supported images. The SQL VM images are rolling out now. We had to make some changes to get NVMe support into our marketplace images, but they're literally like rolling on the train now. So they should be out soon if they're not already there. And there's an FAQ here, so you can determine whether your environment meets the criteria to use NVMe. Okay. How am I doing on time? My clock is broken. Oh, I got plenty of time, right? Got till 11:30, right? Yeah. Sweet. All right, so what do these limits mean? Why do I care about these limits? Well, if you try to exceed these limits, you will be what we call capped or throttled. Throttled is what we've always called it. Azure Storage and Compute, they like to call it capped. I guess it's a friendlier word. So I/O capping. How does this work? All right. I told you there's multiple limits, right? There's disk level provisioning, SSD level provisioning, VM level provisioning, and we just had this conversation of, like, it might not be enough at the VM level, even if it's you attach an Ultra Disk to it. Yeah, the Ultra Disk gives you lots of IOPS and throughput, but the VM doesn't, right? So how do we pull all this together? So in my example here, I have E8 DSV5, not the B, the DSV5, because you're not going to get capped on an EBDSV5, right? So 12,800 IOPS and 290 megabytes per second of throughput. And I'm pretending like I've attached a premium SSD P10. The P10 gets 500 IOPS and 100 megabytes per second of throughput. And I have my SQL Server sitting on this E8 DSV5. Okay. SQL Server is some kind of workload which is generating 10,000 IOPS. So let's imagine that 10,000 IOPS is spread across the 3 data disks that I've attached. 1,000 IOPS is going to one of the disks, 4,500 is going to another, 4,500 is going to the other. So whatever that is, like data, log, tempdb, I don't know. Let's imagine that. So are those P10s capable of delivering 4,500 IOPS? No, they are not. This will not work. This will get capped. You'll get 500 IOPS back from each of those disks. And that means that SQL Server, while it asked for 10,000, it will only get 1,500. What does that mean for you and your users? What will happen? What's that? They're sad, yeah. If you're a DBA, what will you see? What's that? Higher latency, yep, you'll see higher latency. Your disk latency will start going up, as measured from a number of different places. Azure Metrics just released a disk latency metric that you can see in the portal, which is measuring from I kind of think of it as the base of the VM. So the guest OS, you have the I/O stack in the guest OS, and you can measure that through perfmon. The Azure monitor metric is sitting below that in the hypervisor level, and so that's giving you from inside the host out to remote storage and back. So if you're getting capped, even that latency will go up, okay? So you'll see latency. What else might you see? What? You could have timeouts. You could have, if you're looking at waits and queues, you could have I/O waits, page I/O latch waits, right? So you will see this. This will be noticeable, okay? So that's what that would look like to you, and then maybe that could get passed on to your users if it's so severe that it's making your application slow down. Okay, that's not gonna work. Let's go to P30s, which I told you. Let's try P30s. P30s, let's imagine the same scenario. Will this get capped? Where will it, yes, it will get capped. Where? If I'm spreading out the I/O, so one disk is getting 1,000, the other one's getting 4,500, the other one's getting 4,500. Will this get capped? No, not at the disk level, right? It'll get all that. What about at the VM level? Will we get that at the VM level? Yes, we will get 10,000 at the VM level because the VM supports 12,800, okay? This will work fine. All right, let's imagine that your application workload has increased and now you're driving 15,000 IOPS. Now, you're sending 5,000 to each disk. Will this get capped at the disk level? No, not at the disk level. It'll be fine at the disk level. However, will it get capped at the VM level? Yes, it will. Now, is that bad enough for you to have latency? Well, I don't know, that's pretty close. If it's temporary, it might go away and you might be fine. But if it's sustained, you might start seeing problems. Yeah. It's across the whole three. That's the VM level. That's basically how much network you can push out to the remote storage. That's why there's a limit there, because there's only so much network bandwidth that's allocated to the storage. So that network pipe is what we're limiting there. So it's the whole VM, all the disks attached. The ones that are remote. The local one is not subject to this limit. The local one has its own limit, the SSD provisioning limit. Okay, so how do you know if you're getting capping? Well, you can certainly just continue to monitor the things that you're monitoring today, I/O latency, queue limits, things like that. There are also Azure monitor metrics that can help you. So you can build yourself a dashboard. And for this, for the disk level capping, there's data disk IOPS consumed percentage and data disk bandwidth consumed percentage. You will have these counters for each disk that you have attached to your VM. So you can monitor that at the disk level. At the VM level, there are VM level counters, both cached and uncached. So if you're using caching, you would look at cached IOPS consumed and cached bandwidth consumed. And then for uncached, similarly, uncached IOPS and uncached bandwidth. And this is a percentage. It's how much of the total available IOPS and throughput are you using. Okay, so if you're at 100%, you're probably getting capped. Now, if you hit 100% once in a day, no big deal, don't upsize. But if you're constantly redlined at 100%, probably need to address that, okay? All right, now, one thing I put a plug here. We are definitely working on trying to get some of these metrics available to you in the SQL VM virtual machine blade. So I'm hoping to put something together for you that I was hoping I would have a preview for you guys here, but we didn't hit that mark. But we'll be having something coming soon, hopefully, that kind of gives you some insight into this condition in the virtual machine blade. For now, definitely set up a dashboard with those Azure monitor metrics, and you can monitor this. Yep. Yeah. Yeah. So if your machine is capped, is the VM level cap being applied equally over the disks? No. It's kind of whoever's generating the I/O. This could all be coming from one disk. Like it's kind of like the order. It's a queue, right? So think of it as the 3 queues are feeding into 1 queue. So if the 1 queue is the one that's got the limit, it's not necessarily dividing it evenly. There's no like round robining or anything happening. It's just whoever's I/O goes first, that's the one, right? Okay. Okay. Host caching. So I've been talking about host caching. It is available at the disk level, so you can turn it on. We do recommend, if you want to use caching, that you use read-only caching, because SQL Server cannot take advantage of write caching, because it would cause potentially consistency issues, because we can't guarantee that it's D-staged, right? And when SQL Server writes to the transaction log, we do a force flush anyway that like flushes it out to physical storage. So we have to guarantee that it's there. So do not turn on write caching. we can't take advantage of it anyway. So you can use read caching on your data files. Just don't caching should be set to none for log files. And if you want to use read caching, set to read only for your data files. If you use our VM provisioning workflow through the portal with a marketplace image, we configure all this for you based on our best practices. Okay, so here's how caching works. If the data is not available in the cache, then your VM sends the read request to the cache. It's not there. It goes to the disk. It puts it in the cache, and then it comes back. These reads are counted towards both the VM cache limit and the uncached limit, because you also had to go to remote storage. So this would count towards both. Okay. If the data is available in the cache, then the read request hits the cache and comes back. This read is only counted towards the cached limit, but not the uncached limit, because you never went to the remote storage. So that saves you a remote IOP. Write operations always have to write to both the cache. Even if you don't have write caching turned on, we have to write to the cache. So it hits both the uncached limit and the cache limit if you do a write when you have read caching turned on. So let's redo our scenario, imagining we had read caching on the disk. So 15,000 IOPS. I'm breaking it down. I'm sending that into the cache. I'm imagining that 30% of those IOPS are coming from the cache, which means only 3,500 are going out to the disks. Now, this is this is just an example. This would probably never happen exactly like this in reality, but the point is, if you get some of those IOPS out of the cache, then they never go to the remote storage. So you're able to only send some out to the disks, which means you get those back, but you get the rest from the cache, and miraculously, you're not capped, okay? So that's a best case scenario. The ifs on that. If you can leverage caching. If your workload is not one that benefits from the cache, because remember, SQL Server also has a buffer cache, right, which is separate from this. So your mileage may vary on how much benefit you'll get from the cache. In the testing that we were doing, the ballpark is 30% benefit, which is why we use that number. But the reality is your mileage may vary, so you would really need to test this. In most VMs, it's just a no-brainer, because the cache limits are higher than the uncached limits. So even if it doesn't help you that much, it's free, turn it on, right? It's free. So that was our recommendation for a long time. The problem, though, is with Premium SSD v2, sometimes the cache limits are lower than the remote limits. And that happens particularly on throughput. Usually the IOPS limits are higher, but the throughput limits may be lower. So we kind of have to get a little wishy-washy with the cache recommendation on EBDS v5. And this is one of the reasons why we really recommend Premium SSD v2, because you can get plenty of IOPS and throughput on Premium SSD v2 at a reasonable cost. You've got plenty on EBDS v5. And also, one of the caveats of Premium SSD v2 is it doesn't support read caching yet, but that doesn't really matter so much in EBDS v5 because there's so much I/O throughput, remote I/O throughput included. So that's why we say EBDS v5 and Premium SSD v2 better together. If you're using these two, if you're using EBDS v5, we encourage you to try Premium SSD v2 if you can, and vice versa. If you want to use Premium SSD v2, we recommend EBDS v5 because then you don't have to worry about the read caching. Okay, so these two go together. And if you are on EBDS v5 and you are using Premium v1, if you have high throughput workloads, so data warehousing type workloads, not your transactional workloads will generally drive up IOPS, but they may not have high throughput. Your data warehousing type workloads will drive up throughput, but maybe not IOPS. So if you're high throughput, you probably want to turn off caching. And we found this when we did our own benchmarking. TPC-E could take advantage of caching. TPC-H was better if you turned the cache off. So I know a lot of you may not know what your workloads are like. So that's why I say the safest thing is to just turn off caching and use Premium SSD v2. But if you have the ability to test your workload, try it out. It might benefit you. It might not. Depends on your workload. Okay?
Sorry.
Yeah. 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 So the question is, okay, so I'm using this host caching. It goes into the host cache. And then it goes into SQL Server's buffer cache. So don't I have the same data in both caches? Yeah, potentially, which is why your mileage may vary, right? But it may allow you to have lower memory because you can rely on both this cache and the buffer cache. So, and again, a lot of people want more memory. This read cache might even help you with that. So yes, your mileage may vary. I would love to have like a native caching layer in Vicar. I would love to have a native caching layer built into SQL Server that could take advantage of that. I would love that. A show of hands for how many people would like a caching layer in SQL Server that could take advantage of that super fast NVMe drive that's ephemeral for free. Right, it's just built into SQL Server. All you have to do is upgrade to the latest version. Unanimous. Okay, thanks guys. Also, someone else is sending me an email. It's something else I'm gonna bug you about. Okay, cool, great. Okay, so I gave you a lot of best practices. You're not gonna remember all of them, that's okay. I have them all documented. aka.ms whack SQL IAS perf, which I have on a slide somewhere. Oh, don't worry, you don't have to memorize that either. But also, we have some tools to help you do this. So use our marketplace images. We have a storage configuration. This is I'm sorry, actually the black is probably not great. This is our old storage configuration, which works for Premium SSD v1. And unfortunately, David had to leave us, but he's working with our engineers on a new experience for Premium SSD v2, which really kind of helps you do this. And I think I have 9 minutes, so let's try to do a quick demo of this for you. We are hoping this will go to public preview soon. And I know you will. Oh, I closed Discord. Oh, sorry. Let's not have that happen again. Quit. Okay, let's come up here. Hopefully I didn't time out. Okay, so if you come in and create a virtual machine using one of our marketplace images, we have some code that kind of tailors the decisions you need to make for SQL Server. So you come in here, you put in the basics, you give your virtual machine a name. Okay, you put it in a region, you choose an availability zone. I'm gonna turn off trusted launch. And, oh look, I can use NVMe. So again, I choose the E4 BDS v5 here. So I could go to the advanced tab if I want to, and I could check yes, I do want higher performance with NVMe. And then I'm gonna come to the SQL Server settings, and there's many different things you can configure with the SQL Server settings, but what I wanna talk to you about today, since we have limited time, is the storage configuration. So you notice right here, I have chosen on your behalf Premium SSD v2 because the choices you have made enable it. They allow Premium SSD v2, and also we recommend if you use double sprinkles VMs that you use Premium SSD v2. So I'm defaulting you to that, and let's choose change configuration. And notice what I have for you here, the IOPS and throughput limits for this virtual machine. So you have them up front and center. You know how much this VM can do through that magic API we were talking about earlier. And so you can see right here how much IOPS and throughput are available. We've recommended Premium SSD v2 to you. We're obviously going to recommend you separate data and logs. So here's your data. Now, right now this is one data disk because you can do these requirements with one data disk. I'm defaulting to 50-50 data and logs. Most people are not 50-50 data and logs. I don't know what the right answer is here, so we just went with 50-50. But you can change this. So I need more than 1 gigabyte. I don't know. Let's make it 10 terabytes. Okay. And now I think I need, so let's see. I have 14,000. I think I need, let's go with 10,000 for data and 4,000 for logs. So 10,000 IOPS. And okay, so you see what it's telling me right here? It's saying the desired performance might not be reached due to, oh, my zoom in, oh, there, come on. Right, so the desired performance might not be reached due to the maximum virtual machine disk performance. It can only go to 14,740. Why is it higher than that? Because I've allocated some to the log here. So if you go under the log, see it has 7 here. So let's just make this 4,000. And then, okay, the warning goes away. Okay, it does support this, so we're good. Okay, so let's go here, and we have 175, but let's say it's the data warehouse, I need tons of throughput, right? So let's make this, I don't know, 5,000. Uh-oh, okay. Now, a couple of things have happened here. First of all, with 5,000 megabytes per second of throughput, I have to have multiple disks. I can't do that with just one, because one premium SSD v2 only goes to 1,200. I need more. So I gotta build a storage pool in order to do this. I can only attach 8 drives to this machine, so it's telling you, hey, between this and what you asked for in the log file, I can't give you this much. So see this red error? Hey, I need 9 disks to do what you asked me to do, and you only have 8. So I'm warning you right here, hey, this is not gonna work. Okay, so let's bring this down, let's say 2. Let's see if that works. Okay, errors go away, we're all good. But notice I now have 3 data disks because I need a storage pool to get up to that much. So plus, the other thing is, by the way, you might be thinking, I thought it was 1,200. Yeah, 1,200, 2,400, and we're also giving you a little buffer. So we're only going up to like 85% of the capacity, and then we'll bump you up to another disk. The reason we do that is so you have room to grow if you want to. So if you're too close to the maximum capability of a single disk, we'll bump you into a storage pool, or we'll bump you into an extra disk, just so you have room to grow if you need to. Otherwise, you might have to attach a new disk to grow, and that makes things complicated. So we're giving you a little buffer there as well. Because remember, you can size up IOPS and throughput on each one of these drives as well after it's deployed. So we wanted to make sure we gave you a little wiggle room there. So the other thing you might have noticed as I was scrolling is we're trying to put some cost in here. When you start bumping up throughput, the cost is going to start going up. When you start bumping up capacity, the cost is really going to start going up. And one of the things, if you've ever used this deployment experience, you'll know it tells you how much the VM costs. It doesn't tell you how much the storage costs. So you may come out of this thing with a crazy bill for storage. And the thing about the storage is the VM, you power it down, you stop getting charged for compute. You can't do that to storage. That storage bill just keeps ticking, right? I got burned in that in my test subscription. I'm like, why did I get shut off? I hit my budget limit, and then I was like, oh, the storage. Right, I turned the VM off, but the storage meter is still ticking. Okay, so these costs can balloon. So we wanted to just give you some idea of how much the storage is going to cost. So that's in here as well. Okay, so you can see here, and you can type numbers or you can use sliders if you're a slider person. And you'll notice that they're tied together. Like if I try to make this too low, it's going to say, hey, you can't do that. You have to have at least 3,000 per disk. So there's a lot of logic. Everything we talked about today, we tried to build into this wizard. It's complicated, but it's worth it. And I hope that we can get this to you in public preview soon, because I do think this will really help kind of drive the point home of how to configure this according to your needs. Okay, sorry. So let me just quick come back. I think we just have a few last minute slides, which is good because we've got 3 minutes left, right? So best practices that we talked about. Now, for the most part, your SQL Server best practices are the same. They don't change in Azure VM. So follow your SQL Server best practices, but make sure you choose the right VM, either by using your own monitoring or by using the migration assessment that's built into Azure Data Studio. Of course, continue to isolate your files, data, tempdb log. Turn on host caching if it makes sense for you. We talked about the caveats there. Optimize, turn on compression, all the good stuff you have in SQL Server. Use that to minimize your IOPS and throughput. Use tempdb for on the D drive. Oh, there's a couple other things. If you're on the M series, you can use Write Accelerator. One more thing I should change this slide. The other thing is, if you're on older VM series, upgrade them to newer VM series, because there's all kinds of goodness that you might get for free. You might get more IOPS, more memory. There's like network isolation, accelerated networking. There's all kinds of stuff you get on the newer VMs that just built into the new VMs. So if you're on older VMs, I definitely encourage you to upgrade. If you're on V3s, V4s, go to the V5s. You might be able to get a lot more performance without even increasing your costs. You might even lower your costs in some cases. Okay, so definitely take a look at that and leverage the Azure Monitor that we talked about. Okay, so I'll leave this up. Yeah, I'll take questions. I'll leave this up for you. References I talked about. So these are our different checklists. All the best practices I talked about are fully documented in our checklist. I saw some folks taking pictures. I will make sure that the slides get uploaded. I was literally tweaking them 10 minutes before I walked into the room, but I'll make sure they're uploaded so you can get this deck. And then I will stay and take questions, but I'll leave the evaluation slide up to you, because if I can improve this presentation for you, I want to do that. So please give me your evals. And now I got a question over here, and then I'll come back to you guys. Yep. If you're on SSDV1, how do you get to SSDV2? Is your SSDV1 in a storage pool? You rebuild the storage pool. Yeah, if you're not in a storage pool, I do think Azure Storage has created a way to migrate. Yeah, go ahead. What? Glitter? Glitter V2. So sprinkles versus glitter. If KillaDBA writes me a song about double sprinkles VMs and glitter storage, yes. You heard it here. New song from KillaDBA. Okay, cool. Yeah. I need to go check because I know they were thinking of doing that, but I haven't verified that with them. So I have to look up the documentation and find out. But if it's in a storage pool, I know for sure it doesn't work. Yeah. So that's the part. So you can create a snapshot and then create a new disk from a snapshot. That's how you would get from Premium V1 to Premium V2. But as my understanding is, it doesn't work if you're in a storage pool, because of the way that, because the guest operating system is building a storage pool on top of that storage, and for some reason, like the one numbers don't line up, so it doesn't work. If it's a standalone disk, it should, but if it's in a pool, it probably won't. The storage pool is a crappy design. I will pass that along to the Windows team. I will. In fact, I know someone for that. So yeah, okay. I heard, feedback heard. I will pass it along. Yeah. Oh, max storage capacity. It was on the slide. I don't even know that one by heart. Hang on. I gotta go back too many slides. Okay, it's on a slide somewhere. It's in the documentation. There is a max. I think it's 80 terabytes or something, TB bytes. But I can get that for you. We are, I think, officially out of time. Yeah, we're officially out of time. So I will absolutely hang around to answer more questions. But for those of you who want to leave, thank you so much for joining me. I hope you enjoy the rest of your summit. Come see Taryn and I again in room 6B at 4:45 today. We'll talk about HADR. Thanks, everybody.